Hello, you're welcome to Prepclass Tutors. I am Abel, and today I'm going to be taking you through some WAEC mathematics past questions for the year 2020. Now, our focus will be on questions 46 to 50. But then, I would like to remind you, like and comment on our YouTube videos. Yes, this keeps us moving and gives us the support that we actually desire in order to maintain this production. So please don't forget, like and comment on our videos. So let's proceed to question number 46. Question says, a woman received a discount of 20% on a piece of clothes she purchased from a shop if she paid $525. What was the original price? So a shop owner possibly was selling a particular cloth for a certain amount, but then he decided to, or she decided to give a discount. Now, if someone pays $525 for the same article, what do you think was the original cost of the article? So to do that, there's something I would like us to remember, very important, though, and it's looking simple too. There's this formula here that says the total is equivalent to the quantity all over the fraction. What does that mean? You can see this in application in this particular question. So what it means is that if we know a portion of the total and what fractional equivalent that portion is, then we can use this relationship to get the original quantity. So in this case, original price is equal to this quantity here means the amount of money she pays. In this case, 525. And here, the fraction we're looking at is 80% because she was given a rebate of 20%. So it means she actually pays 80%. And in that regard, we're going to use 0.8 here because this is 80%. That's 80 over 100. So by the time you divide 525 by 0.8, you're going to have 556.25. It seems the unit here is a little bit of concern, but you can ignore it as they use dollars here, and actually the unit is supposed to maintain dollar equivalent here too. So the cloth purchased initially cost 556.25 cents before the rebate, and that is reflected in option C. So proceeding to the next question. It says the interquartile range of a distribution is 7. If the 25th percentile is 16, find the upper quartile. Okay, the formula for calculating interquartile range is given to be the third quartile minus the first quartile. Now, the first quartile is the 25th percentile. And the concept of percentile is a little bit different from that of percentage. Please don't mix the two. When we talk about percentile, it means, for example now, let's say in a class of 100 students and someone scores, let's say 52 out of 100, the marks, because the test happened to be gauged overall on 100 marks. So if the person with the mark of, let's say 52, is more than 25 people in the class, then you can say that 52 score is actually a 25th percentile score. So this is a reflection of the particular people that the score is ahead of. So when we talk about Q1 being the 25th percentile, we mean that 1/4 of the total actually fall under this category. So the 50th percentile is our median, which is the Q2. And here, the Q3 is the 75th percentile, which the difference between it and this 25th percentile produces what we call the interquartile range. So in this regard, we are looking for the upper quartile, which is the 75th percentile, and here, which is also the Q3. So Q3 minus 16 is equals to 7, making Q3 the solid of the formula. Taking this 16 to the other side, we have 7 plus 16, and that's going to be 23. So our Q3, which is the upper quartile, is 23, and this is option C. Proceeding to question number 48, it says the graph of the equation y is equivalent to 2x plus 5 and y is equivalent to 2x plus x minus 1 as shown. Use the information to answer your question. So here we're required to use the information on the graph to answer question 48 to 49, and the graph actually will be shown to us in the next slide. So here we need to note this, that this is an equation of a straight line, whereas this is an equation of a curve, a quadratic curve precisely. So the question wants us to find the point of intersection of the two graphs. So let's proceed. Now, this is the curve for this equation. Y is equivalent to 2x squared plus x minus 1. And this is the equation of the straight line, as you can see, for y is equivalent to 2x plus 5. Now, they intercept at this point and also at this point. So we are required to find the point of intersection for the two. What it means is that we need to know the value of x here and what equivalent the value of y will be here, and do the same thing at this point too. So here you can read this from the charts without even solving this analytically. Yes, you can read it from the charts straight. Now, solving this algebraically, as you can see, this is just a rough estimate. This is our coordinates, just trying to replicate it. This is a curve, and this is a straight line A, B, where the intersections occur. So this is the equation of a straight line, this is the equation of a curve. You will understand here that at the point of intersection, the value of y is the same as the value of x on both the straight line and on the curve. So this permits us to equate the two equations here. And here we need to rearrange this to form a quadratic equation, as you can see. So by bringing everything from this left hand side to this other side. So 2x crossing becomes minus 2x and 5 crossing becomes minus 5. So everything here turns 0. So this will leave us with 2x squared minus x minus 6 is equal to 0. So now solving this in the quadratic approach, we'll remember that 2x squared times minus 6 will give us minus 12x squared. So we need to look for the factors of minus 12x squared whose summation will give us minus x. And this will happen when we use minus 4x plus 3x in the portion of this minus x. So we're looking at the factors of 12, 4, and 3. And the higher number will have the minus sign because of this middle sign here in order to achieve that. So from here, we need to just collect terms, like terms here. 2 and x are like. So as you can see, if we say 2x times 2, 2x times x, we have 2x squared. And 2x times minus 2, we have minus 4x. And this, if you open these two, you have this, as you can see. So now we have two similar brackets. It means we can take one and then enclose this 2x plus 3 also. So this is the quadratic equation that we have here equal to 0. So from here, we're meant to understand that if this bracket times this bracket is equivalent to 0, it implies that is either x minus 6 equals to 0, which will give x to be 2, or 2x plus 3 is equals to 0, which will give x to be minus 3 over 2 by dividing both sides by 2, having taken the 3 to the other side to become minus 3. So now, We now understand that at this point A and B, the value of x is either 2, sorry, the root of the quadratic equation will be 2 and minus 1.5. So we need to know or track the value of y, the corresponding value of y at these 2 points. So at x is equals to 2, y will be, we can use any of the equations to get it. You can also use the quadratic equation or the linear one, but I choose to use the linear one for the sake of convenience here. So 2 times the place of the x, we put 2 plus 5. So this is going to give us 4 plus 5 is going to be 9. So it simply means at point x is 2, y at that point is 9. So this is it. This is the order. This is the pair. Now, and at x is equals to minus 3 all over 2, which is minus 1.5, it means we substitute the value of x here. 2 cancel 2, as you can see, minus 3 plus 5. So this is going to give us minus 3 plus 5, and that's 2. So it means at x is minus 1.5, our y is going to be 2. So that means that the point at which these equations intersect will be 2, 9 and minus 1.5, 2. So this, as you can see, is supported by option A. So looking at question 49, remember we use the knowledge of the graph from the previous question to answer question 49 also. So it says if x is equals to minus 2.5, what is the value of y on the curve? So simply we just need to come to minus 2.5. As you can see, this is minus 2 and the interval here is 1 unit. So minus 2.5 should be somewhere here, the middle between the two values, minus 2 and minus 3. So at this point, if I want to get the value of y on the curve, I just need to go straight vertically up. And by the time I touch just the curve, I take a horizontal movement to the y-axis and see what will be the value of y at that point. So by the time you do that and read carefully, you will discover that it happens at this point. So it happens at a point in which it will be somewhere between 5 and 8. Yes, this is a little bit lack of straight movement. So it will happen in between 5 and 8, and it will be somewhere around 8.5, because you will discover that by the time you break the smaller boxes, there are about 5 of them. So it means each box represents 2 units. So by the time you do this on the graph, you discover that you would have crossed 3 of them. And on the fourth one, it will be split into 2. So this gives us somewhere close around 8.5. So this, as you can see, is supported by option B. So finally, looking at the last question in this particular set, it says if x plus 2 is a factor of x squared plus px minus 10, find the value of p. So this is a reminder theorem question. So, and don't forget that if x plus 2 is a factor of x squared plus px minus 10, then it simply means that this actually is equivalent to 0. Yes, from Remender's theorem. So that means that the factor will be equivalent to 0. So from here we can get the value of x at which it will make the equation 0. And here, making x the subject here, we have x to be minus 2. So it means by the time we put minus 2 here, everything should automatically turn to 0. So at this point, we're going to substitute the value of minus 2 here and see. So minus 2 squared plus minus 2p minus 10 is equals to 0. So minus 2 squared is going to give us 4, plus times minus 2, we have minus 2p minus 10. So here, 4 minus 10 is going to give us minus 6. We have our minus 2p here. And rearranging this to this other side, we have minus 2p is equals to 6, dividing both sides by minus 2. As you can see, minus 2 cancel minus 2. So this gives us 6 all over minus 2, and this is going to be minus 3. So it means the value of P in this equation is minus 3. And this, as you can see, is supported by option B. So with that, we've come to the end of today's program. And please don't forget, just in case you're just joining us, do well to like and comment on our WhatsApp videos too. Until then, have a nice day.